Okay, so picking up where we left off, I had just drawn in my F2 with its X and Y, and there's an F3 in this one, which is 78 newtons east 15 degrees south. East 15 degrees south is going to be in here. Okay, so this is 15 degrees. This will be F3. It's 78 newtons. So this will be F3x, and this will be F3y. So now be careful. There's two different components this way. One is F3x and the other is F2x. Okay, so then we go to our breaking them down, and while the video was uploading, I listed them. So F1x ends up becoming 7.51 newtons, and that's west. And F1y is 47.41 newtons, and that's north. F2x is 27.69 newtons, and that's east. And F2y is 54.35 newtons, and that's north. And then F3x is 75.34 newtons, and that's east. And F3y is 20.19 newtons, and that's south. Okay, so then do the sum in the x direction, and when you do, you get 95.53 newtons. East, east, and west, east winds. And in the y, sum of the forces in the y, you have a north, and a south. You end up with 81.57 newtons, and it's going to be it's going to be north. Okay. Didn't leave myself enough room, but over here, east, north, square them, add them together, take the square root, and get your F net. And when you do, you get 125.62 newtons. Maybe I'll write it down here. So 125.62 newtons, square bracket, east, and the angle is 40.49 degrees north. And so then your FEQ is just going to be opposite that, 125.62 newtons. Instead of east, it'll be west. 40.49 degrees instead of north, it'll be south. I forgot to change color, sorry. And you're done. All right, number 2 is exactly the same, except there's a big long story with it, but it's exactly the same. 3 young children are pulling on a stuffed animal. Amy is pulling with the force of 15 newtons north, 58 degrees east. Sorry, just trying to find the edge of my page here. So north 58 degrees east is going to be here. This is 58 degrees from the north. And she is pulling with a force of 15 newtons. So if we draw our components in, this will be F1y, and this will be F1x. Okay? Buffy is pulling with a force of 18 newtons south, 23 degrees east. So down like this. So F2 is 18 newtons, and this angle is 23 degrees. So this will be your F2y, and this will be your F2x. So again, find the components. So F1x will be 15 newtons. Now be careful, it's the opposite side this time. So it will be sine of 58. And F1y is the adjacent side, so it'll be 15 newtons cos of 58. So they changed it up here just so that you don't get too comfortable with thinking that it's always sine for one and cos for the other. Okay? 15 newtons, so this should be 12.72 newtons east, and this one should be 7.95 newtons north. Now, as you're sitting there wondering, yes, you could do cosine and use the other angle. If you did, that other angle would be 32. You will get exactly the same answers. Okay, so there are my first two components. F2x is down here. Again, it's the opposite side. It's going to be 18 newtons sine of 23, and F2y is going to be 18 newtons cos of 23. So F2x ends up being 7.03 newtons east, and F2y ends up being 16.57 newtons, and that's south. Sorry, I'm trying to hold it and write, and so it keeps moving because I'm writing. All right, so add up your east to get your total in the x direction, and it should be 19.75 newtons east. Add up your total in the y direction. They're opposite, so you're actually going to have to subtract, and you should get 8.62 newtons south. Draw your picture east, south. This is 8.62 newtons. This is 19.75 newtons. This is your F net. Square them, add them together, take the square root, and it will be 21.55 newtons. And it's going to be east 23.58 degrees south. So what force does the other person have to pull with to balance it out? 21.55 newtons, and instead of east-west, 23.58 degrees instead of south-north. Okay, so hopefully those make sense to you. All right, now number 9 is a little bit different, but it isn't. But it could have messed you up. Okay, so it says a traffic light hangs in the center of the road from cables as shown in the figure. If the mass of the traffic light is 65 kilograms, what force must the cables exert on the light to prevent it from falling? Okay, so look at where all these things meet, because that's where the forces are acting. So at this point, you have an Fg going down, which you can find. It's just mg, and they told you the mass was 65 kilograms. Here you have two tensions going up, and it tells us the angle up here is 12 degrees, which means the angle down here is also 12 degrees because of alternate interior. So this is like F tension 1, and this is like F tension 2. They're going to be identical simply because the angle's the same. If the angles were different, they wouldn't be. But because the angles are the same, it means they're both supporting half the weight. Well, F tension 1 has an x component going this way, and F tension 2 has an x component going this way, and they should cancel each other out because this thing isn't moving. Ft1y and Ft2y should be equal, okay? And so you're going to do sum of the forces in the y direction. Sum of the forces in the y direction have to equal 0. So you have Ft1y going up plus Ft2y going up minus Fg going down. These two are the same. What are they? They're the opposite side. So they're going to be Ft sine theta. And there's two of them because we already said they're equal. So 2 Ft sine theta. Take your Fg over. It's mg. And you're solving for Ft. So Ft is going to equal mg divided by 2 sine theta. M was maybe 65 kilograms, 65 kilograms. 9.81 meters per second squared, divided by 2 times the sine of 12, and find your Ft. And when you do this, you should get an Ft of 1,533.5 newtons. Now, if you don't believe me that the Ft's are the same, then we could have started by doing the sum of the forces in the x direction. Has to equal 0 because it's at rest. There are two. There's Ft1x minus Ft2x equals 0, which means Ft1x is the adjacent side, so cos theta equals Ft2 cos theta. Cos thetas are the same, So FT1 must equal FT2.